Assalamu alaikum. How are you, class? Fine. I welcome you all into my class. I am Muhammad Ikram and I am your physics teacher. Today we are going to start from the very first chapter, that is unit number 11, electrostatics. So today I will teach to you about the electrostatics. Today is our introductory class, and before the beginning, I would like to tell you that please don't miss this class. Don't make it forward or backward or like that. Watch the complete video and try to learn the basics of the basics first, because basics are very important, right? Without basics we wouldn't be able even to understand a single physical aspects of the physics. So basics are the most important here. So let us start with the electrostatics. Before telling you something about the electrostatics, I would like to start with the electricity. What is electricity? In fact, electricity is the invisible force which produces 6 effects, and hopefully you all know about those 6 effects of the electricity. You came across with these effects many times in your daily life. For example, the first effect of the electricity is light, and you see today that whatever I am teaching to you right now, that is all because you see me because there is a light. If there is no light, you wouldn't be able to see me. So that is because of what? That is because of the light. I'm sorry, I forgot the duster. Let me take it. The second effect of the electricity is heat, and you all familiar with this effect. For example, electric kettle, electric iron, you all see this effect there. There is motion also. It produces motion also. And then there is another effect also, motion. For example, motion, you see lock, for example, the electric fan, you see the electric, even the electric train, the electric car, they all produce what? Motion. So electricity produces motion also. And the third one is sound, right? For example, you might see the electric guitar, right, which produce most pleasant sounds for you. So electricity can produce sound also. Another important point is the magnetic effect. This is also very important, that electricity produce magnetic effect also. For example, look at the electromagnet, which is used in various appliances. For example, the magnetically variated trains, the crane, which use this magnetic effect to lift heavy objects for you, such as the container at the seaport. There is another effect of the electricity also, and that is the chemical effect. For example, electro sorry, electroplating. It is one of the chemical effect of what, of the electricity, and this make it possible to deposit the layer of one metal on another metal, or the layer of one element on another one. So that is all possible because of what? It is possible because of electricity. So electricity is in fact the invisible force which can produce these six effects. Now why I say the invisible force, for example, because you see when the electricity moves through the wire into the wire, we can only see the effect, but we cannot really see those charges moving. So this is why I call it the invisible force, that electricity is in fact what? That it is the invisible force which can produce these six effects. Right now, then, this electricity, the question is, where does it comes from? Why the electricity produce all these effects? How electricity is able to produce light, to produce heat, motion, sound, magnetic effect, and chemical effect. This is what we will learn in our this SOS. So you see this electricity, right? We divide into two broad classes, two broad types or categories. One we call the electrostatics. The electrostatics. And the other we call the current the current electricity. Whether the electricity is the current electricity or whether if it is electrostatics, there is one thing, and that one thing is the source or the cause of this invisible force is what? It is charge. So here we will discuss this thing. In electrostatics, we will discuss charges at rest. There is a question that whether the charges can be at rest, right? What are charges? Whether they can be at rest? If yes, how? And the second is the current electricity, the charges in motion. So here we will study what? Charges at rest. And here we will study charges in motion. This kind of electrostatic has its own applications, right? For example, there is the charges at rest. This kind of physics, this kind of electrostatics is also the most important in our daily life. For example, you see the laser printer, the photocopier machine, they all work on the principle of what? The principle of the electrostatics, where the charges, where we discuss the charges at rest. And now I'm coming to that point, the current electricity, and here the examples are that when the charges are in motion, then they can produce these many effects for us. So let us start with our topic, electrostatics. What is electrostatics? We will discuss right now the electrostatics here. So electricity has two main types. Now let us start with the electrostatics. What is electrostatics? Electrostatics is the branch of electricity in which we study charges at rest. Here, what we study? Charges at rest. Now, the question is that what is a charge? This is the bigger question. Now, this is very complicated question, right? And I'll be telling to you why I say this. You see, look, that sometimes we do see the effect, but we do not see the things itself. For example, look at temperature. Can you see the temperature? If I ask, temperature is a kind of physical quantity. So if I ask you, where is the temperature? So you say that, sir, we do not see it, we can only feel it. But if I say light, then you say, yes, sir, we can see the light. Yeah, we can see a particular color. So there are certain kind of physical aspects or quantities which we can see. There are certain things which are abstract, which we do not see. For example, if I talk about the length, then definitely you will see that, sir, yes, this is the length and we can measure and we can see, right? So some physical quantity we can see, some we cannot see. For example, if I ask you about a force is another aspect. Density is another aspect of a certain thing. You can experience or you can feel the density of something, but you cannot see it. So it is not necessary that we should always see it. So what is in fact charge? Charge is the fundamental attribute or characteristic of matter. The fundamental attribute of matter, or the fundamental attribute, or you can say characteristic. Fundamental characteristic are the fundamental attribute associated with matter. Right now, where in the matter? There is exception. For example, if you see, just like, for example, if we say gravity is the fundamental attribute or aspects of matter, in the same way, there is exception. Not all the matter. For example, what I mean to say, right now at this moment, I will talk about proton. It is matter, and it is the attribute of matter, and I would add electron. And it is the electron is also a matter, but there is exception. For example, neutron is a matter, but it is not the fundamental attribute of the matter, though the particle from which the neutrons are made, they have also this attribute, right? And you might have heard about quarks, and inshallah we will discuss the those attributes there. So the electric charge is the fundamental attribute or characteristic of matter, right? Or I would like to say, if I put some concept into it, then I would like to say that a charge, I would like to tell you that this charge is in fact the smallest quantity. The smallest quantity of what? Of electricity found on the matter. Matter, proton or electron. So that is one of the fundamental characteristic or attribute of proton and electron, which we cannot remove from them. In the same way as you cannot remove temperature from matter. Wherever you go, to which part of the universe you go, if you find matter somewhere, matter has the attribute temperature. So similarly, the proton and the electron have this fundamental attribute and this characteristic. Now this charge, it is the fundamental or the intrinsic, sometimes we can call the natural or the intrinsic property of the proton electron, which we cannot remove from them. Now what does that causes? This electric charge, this attribute has the ability to cause or produce what? This has the ability and has the ability to produce electrostatic force. Just in the same way as matter causes gravitational force. So in the same way, the charge produces electrostatic force, right? So now let me tell you about some properties of this electric charge, some characteristic or properties of the electric charge. What are the properties of this electric charge? So as I told you that electric charge is the fundamental characteristic or attribute of matter which produces the electrostatic force. So that is what we call the electric charge. Some of the properties of the charge I would like to explain. Few you have learned in class 10 and more you will learn here. Properties of the charge, right? What are the properties of the charge? There are some basics and simple properties which I will not discuss because you have learned all those properties in class 10. For example, the first property which you say that there are two types of the electric charge, the positive charge and the negative charge. And you have done experiment also, right? When you were in class 10, then your teacher performed you in an experiment that how many types of charges are there. So the experiment performed there verifies that there are only two kinds of charge. One we call the positive charge and the other we call the negative charge. These are just the name, remember. If you call or if the scientist or the engineer at that time called the negative charge as a positive charge or the positive charge is a negative charge, then still it is okay, right? But they have given the name positive charge and the negative charge, then it's okay, we do agree with it. So only two kinds of charges exist, the positive charge and the negative charge. Now remember class, I just want to tell you another thing also. Beside the positive and the negative charge, there is another term also used, the positively charged body and the negatively charged body. The positively charged body is the body which has deficiency of electron. Positively charged body is the body which loses electrons. Negatively charged body is the kind of body which gain electrons, which have excess of electrons, right? Why? Because you know that the charges can only be found on what? Proton or on electron and no other part, right? And I will be explaining these one by one. So we have this thing that we have the two type of charges, right? The second important point, beside being positive and negative charge, I just like to add to another, let me put it here. That is how charges are produced. This is another thing. How charges can be produced. This question is not a good question because we cannot produce charge, right? We cannot create charge, and later on I will be telling to you in a kind of property these charges neither be created nor be destroyed, but they can be transferred from one body into another body. For example, whatever the number of electrons and protons that are present in our universe, that's all. Okay, we cannot increase them or we cannot decrease them. So this is why this is not just a good word for the production, but still we use it. So how charges can be produced means how we can transfer charges. So there are various methods, right? That if you want to see this, the effect of the charge, then look, we can produce charges by conduction, first by induction. Well, the easiest one first. For example, by rubbing material together. By rubbing. This is what I would like to call friction. One. Second, by induction. And when you were in class 10, your teacher told you about these methods. This is induction. And the another one is by conduction. These are the three methods by which we can produce charge. By the word produce is not a good word, but this is common. We use it in our everyday life of the electrostatics. So this is why I am also using it, although transfer is the best word. By rubbing material together. Which kind of material together? For example, look, this rubbing material together, by friction, by the method of friction, we can create this kind of effect. For example, if you rub this piece of the marker together like this one, then you can definitely produce the electrostatic effects. Let me try. There is the fan on, so maybe it will not pick it up. Yes, it is doing. It is picking up. So what you actually did, that you rub two material together. One, this plastic, this is marker and this is plastic, and one with my hair. So remember, this is applicable only when both bodies are neutral in the beginning, right? Neutral body, I would like to means positively charged body, negatively charged body, and neutral body. Neutral body is the kind of body which neither lost nor gain any kind of charge, right? So that is what we call the neutral body. So we have what? We have the we can produce charges by friction when both bodies are neutral, right? One. Second important point, they must have a different nature. For example, if you rub this marker with this marker, and if you do it for 1000 hours continuously, you wouldn't be able to make transfer of charges. Now the question is why? Because, for example, look, that the charges can only be transferred because if you just look to the nature of the material, for example, any material, and if you see, look, if this is the nucleus where there are protons, and you see that, look, around this nucleus there are orbit where you can have electrons, for example. So you know that the electrons are sometimes loosely bound to the valence shell. The further you away from the nucleus, the electrons are loosely bound, until you have some even free electrons also, right? So what actually you do when you rub material together, so during that rubbing material together, the heat energy causes, that is, the electrons gains that energy, and because of that energy they transfer from one body into another body. So this is why the material must be what? Of different nature. Why? If they are of the same nature, then what will happen? They require the same amount of energy, both kind of, for example, if they have the same nature. So the electron here and the electron here, they have the same nature, so therefore they need the same amount of energy, which is not available to them. So the nature must be different, right? For example, if I just rub this plastic with my hair, like this one. So let's say, for example, if this is plastic, then it gains a negatively charge. So contrary to this, my hair will get positive charge. So during this rubbing, the electrons transfer from my hair to this piece of the marker. Because of what? Because of that energy during rubbing, right? During friction. So that energy causes the electron to transfer from my hair to what? To this marker. Right? So in other way, I will also like to tell you one important thing. Then when you remember this point also, that when you charge bodies, you are also actually making their masses unbalanced. For example, the negatively charged body has always more mass than the positively charged body. For example, if you have two bodies of different nature, if they have the same masses in the beginning, right? And when you rub them together, after rubbing, when they get charged, one body positively charged and the other body what? Negatively charged. For example, look at my hair. Let's see, this is very unfortunate that I cannot tell you this thing here. For example, look, these two bodies which have a different nature. For example, look at my shirt. For example, if this shirt and this marker, you just consider it or imagine that they have the same masses, and when I rub it like this, okay, and if this get negatively charged and my shirt get positively charged, then definitely mass is also disturbed. Why? Because electron transfer from the shirt to the marker. So what happens? The marker have now more electrons than here. So it means that it has more mass. Why? Because electrons are material particle and they have mass. So by charging bodies, you are also actually disturbing their masses. But remember that we cannot see this by measuring, by using ordinary balancer, right? Why? Because the masses of the electron are so small, right? That this does not the masses are so small that we cannot measure them, right? But the physics says that masses must be disturbed also, right? So that is what, by rubbing material together which are neutral and which have what? Different nature, then charges can be transferred. Similarly, by the process of induction, you have learned the electrostatic induction phenomena, and I am not here to explain it to you, but in the electrostatic induction is the process of charging an uncharged body by the help of a charged body without any physical touch or physical contact. So in the case of the electrostatic induction, one body must be charged and the other body must be uncharged. So two bodies having different nature, one charged and one uncharged. This is without any physical contact, right? Second, the third important point here is that of conduction. In conduction, usually this takes place with the help of physical touch. When you touch an uncharged body, particularly metals, with an uncharged body, then the transfer of charge can take place, right? So this is by conduction. So how many methods are there for producing charges? Rather transferring charges. We cannot produce charge. 3. By rubbing, that is by friction, by induction, and by conduction. So there are still two types. Still there will be two kind of charges, whether if the process is friction, induction, or conduction. We cannot have more than two kind of charges. So one is this thing. The next important point here is another important point, that light charge